Right, so this is going to be a continuation of the build video. I've decided for now that this cargo plane is not going to be a VTOL. What I want to do is I want to get it up and flying correctly. It's flying pretty well right now, and then I want to convert it to a VTOL afterwards. Starting it as a VTOL, it's going to be problematic. There are going to be some issues, and so I think by making it a fully functioning aircraft and then attacking it as a VTOL afterward, I think that's going to be a better method. And so I have some thoughts on that as well, on how I want to integrate that. Um, so one of the things I needed to do is I went and did some flight testing, and so it's always best when your center of thrust, which is in line with the engines, are in line with your center of gravity. There's nothing wrong with having high engines or low engines. You just have to realize that's going to cause pitching moments that you have to then counteract. And so one thing I want to do here is so I adjusted and I put the engines on the wings. I also got rid of the tilt function, so our wings no longer tilt. I will bring them back to tilt in the future, but at present they're not going to. That's kind of a decision I made to try to get some better performance out of this, and so I think that's going to pay some dividends at some point. And so let's go ahead and let's continue working on this. And so what I'm going to do is when I do want to make this a VTOL, I think I might, so one of the reasons I, started kind of getting away from the VTOL is, we're going to have some issues with your control surfaces don't like being on separate bodies. So you see my tail plane's on separate bodies, so I'm having some pitch issues. And then with my wings on tilting bodies, I lose some of my control surface effectiveness. And so I might, so one concept I've had an idea for a long time is having a jet that has uh, two engines on the front here that are tiltable, and then two engines that are tiltable on the tail up higher. And so that's going to give me four engines. There'll be smaller engines, less powerful than this, so there might even be these. These are pretty powerful. I'm kind of a little lower in speed than I'd like. I'll go about 280 knots. I'd like to get up over 300 knots. And so that will allow me to kind of dial that in, and it will make it so that the control surfaces are on the main body, which always makes it a little bit easier for control. And so I'm thinking of doing that as well. So definitely have some notions on this and how I want to proceed. And so currently it's a pretty good cargo plane as is. It's flying pretty well. I'll take you out for a flight here in a second, and we'll kind of see where we're at and kind of catch you up on where, what I was up to. And I think that will be helpful. So I moved the engines down. I did a bunch of engine testing, trying to get more powerful engines. We get a pretty good speed now. I'm having to compromise a little bit of efficiency, but it's not much. Um, so right now I have a rotating tail plane. This was kind of my notion. Cleaned up the tail a little bit. So the tail rotates. There are benefits to that and there are drawbacks. So one notion I also have is putting in kind of clamshell doors. So, this works fine, except I lose a little bit of controllability. So one thing I want to do is let's do some controllability tests and see if it's viable to keep the tail like it is. So right here, generally in the front, I'll add some fins in opposition to the elevators. So they go the opposite way of the elevators because they're in the front, and this makes it a little bit easier to control, and it gives me more pitch. In game we don't have the real pitch effectiveness in some of the aerodynamics we have in real life, so you kind of have to change your pitch planes a little bit, and so I'm currently doing that. So let's find where these are connecting. So this is going to be our pitch, and see if I can find the node from here. It's kind of tough to spot. Somewhere right here. Oh, just go up and grab it. Where is pitch? Pitch right here. Stabilized pitch, and then so you just want the arrows opposite to the elevators on the tailplane, the horizontal tailplane. All right, so let's go ahead and let's take a little flight, and I'll show you where we're at. Presently, I need infinite electricity on just because I haven't hooked up any of the electricity. We shut vehicle damage off just to kind of, we have a little bit of a bump. I don't want to have to, have the vehicle self-destruct, essentially. So it's working pretty well at present. Flies pretty well. Fixed some gear issues I had in the last video of, I had some scuffing, so I actually put some XML edited blocks in there. Okay. Oh, I screwed up my APU. I need to fix the APU. The APU is screwed up. So I was, I'm thinking of clamshell doors in this, and because of that, I cut the fuel out. So I need to put the fuel back in here. All right, and I need to put air in here as well. So I've kind of been chopping this APU and Frankenstein it and whatnot. So let's try to cut it because I want to, I might, when I go clamshell, I might need more space. So I've kind of pushed the APU back more. And so I think we'll go to this far anyway. Trying to see where it would, yeah, so be right about here. So yeah, as long as yeah, that's good. So anywhere in here I should be fine. Yeah, that'll be all right. Let's see, what's this? That's a 2 by, are these ones? These are ones here. Okay, good. So let's go ahead and just checking this for spacing. Let's remerge this. So like I don't have any fuel or air connected to this APU. That's why it was having a start issue. So let's go delete that. So just kind of redress this APU, get it going. And you see in a lot of jets, they have the APU in the tail like this. Little compartment that can be plumbed up and they can go work on it. All right, and then I need to put in some fuel, so I will just rotate this. All right, because I can't start the engine currently without the APU, so we definitely want to put an APU in there. All right, and so we have fuel in there now. Let's set to diesel. All right, so this should be fine now. This should work. Just check all the nodes. All right, good. So let's go ahead and we'll spawn this and see if we can get a start off it now. But it's performing well. It's performing well as a cargo aircraft. The VTOL element of it's a little bit gimmicky, and that's going to be, that's a game thing. The complexity for doing something like cargo would be way overblown unless it was, really, well in the future when it's viable, they would do it. It's just technology is not there to make it financially viable. I don't know if I put in the clutch value I wanted. That's I figured out the clutch value I want. I don't think I put it in yet. I have to test out the generators too. Generators were causing me some issues. So. Alright, so should be able to kick the gens on. Alright, let's go ahead and let's taxi out. Let's do a notch of flap. So the cockpit is pretty much the cap air jet. The issue too I'm thinking is if I go to 4 engines, I have to redo the redo a lot of the cockpit because I want actual throttles in there. I might simulate them with up-down arrow keys. I lose I don't really lose it, but I don't have as easy of a time actually doing differential thrust that way. The tail of the aircraft has been picking up first, which is wrong. We should be able to rotate rotate it down. One of the things in real life, they actually tilt the turbines. They actually have some angle of attack built into the wing, and so that makes it so that you're already starting with some angle of attack, and so we can't really do that in game well. And so I kind of have to simulate some things to make that work for me. Alright, so I'm going to keep some back pressure. I'm going to kind of do like a soft field takeoff, trying to get that nose off the ground. See, like the back is picking up first, so I just don't have enough pitch authority, and a big part of that is because something's up. I bet the generator is robbing too much power. I have to redo the gen numbers. Like, yeah, my speed's screaming up now. Like, see, I don't have enough pitch authority, and that is, I think, because the tail is a separate body, and so I'm going to redo the tail system there. This was taken off of the runway fine. I've been doing a bunch of iterations and trying to fix it. I also redid the flaps. Like, see, I have very little pitch authority, so like these fins in here, I can't even see if those are working. Okay, see, the top fins are actually going the opposite way, so I screwed something up there. That makes sense why that screwed up. So let's fix that. I think I put them in upside down because I did them a couple times. I think the first time I made sure I put them in right, and then the second time, yep, see, all 4 of these are wrong, so going to delete them. Come on, symmetry. Yeah, they put these in wrong, and so they need to go opposite the elevators in the rear, so the arrows, the solid arrow should be up on this. All right, let's go ahead and reconnect these. And that should give me more pitch authority in the nose. See, one thing I do is I will trim, so like, this is a trick I have here. So I'm with my flaps. My flaps are not only starting a positive flap, positive lift, but they're having lift and it's behind the center of gravity. So in real life, this wing is creating most of your lift. And actually the curvature of the wings, what the flap's doing. And so that's just integrated in the part of the lift. So the lift should be about center of the wing right here, but it's not in game, it's here. So it looks funky compared to real life. In real life, your center of lift would be probably about the center of the wing here. And as you probably go down the sweep, it's probably kind of sweeping back with the sweep of the wing. In game, it's the control surfaces doing that lifting. So really, you'd want this wing up, and that would look artificially forward. So I need to do things like add some fake lift here. Plus, your center of lift is getting dragged back by your horizontal tail plane as well. So you need to kind of counteract it with some frontal lift as well. And so I have these in here. And so let's go ahead and hook those up. And like, see, when my flaps come in, I have all these tiny little fins. Those counteract the flaps. Because one of the things your flaps are doing in real life that the game doesn't simulate well is they actually give you a lot of drag. And so it allows you to keep your engine spooled up, which is what you want. And so you don't really get the deck angle tilt that you want. You kind of want a nose up deck angle. So you want to be kind of pitched up as you're coming in, and that's one of the reasons you don't flare a jet, is the jet's pretty much pre-flared. And so by putting those counter flaps in there, it's actually giving me the appropriate drag and deck angle that I want. So that's why I do that, make it more realistic. And putting those nose fins in there moves my center of gravity to a realistic place. So I'm doing all these little things in the endeavor of adding realism. Let's put a notch of flaps in there, fuel valve, get that going. That's 5, that is 7, 8. Let's do altitude hold, heading hold. And so I need to retool the generators too. The generators are sapping so much energy off my engine. They really shouldn't be sapping that much energy, but they are. So one thought was so these are pretty much off the Cap Air jet, and so this is considerably heavier. And so I get a little bit worse performance. It's not bad by any stretch of the imagination. I have to go up from 34 to about 45 RPS, and I'm still about 20 knots slower. So one thought is to make some smaller engines that are a smaller diameter. They'll be less powerful, but do 4 of them, because I don't want to really have a ton of fuel use. So see how it's picking up my tail? That's absolutely wrong, and that's, again, because of the center of gravity issue. But now with those fins in there, I'm able to rotate properly and kind of counteract that. So let's go ahead and we'll flick the gear, and we can watch the gear come up. The gear comes up nicely. I'm happy with the gear. Gears function really well. The gear took a bunch of time. Last video I started working on the gear, I think, and then kind of abandoned it and did it off screen because it was just a lot of trial and error. It was fix them, pull them, fix a problem, fix them, pull them, fix a problem, test, 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 test. That was kind of what it was all about. And so it's flying very well now. Good pitch authority now. So, I want to get this set to the point where I don't have to change the tail if I don't want to. So let's go ahead and drag this back in the workbench. I don't need to bother with landing or whatever. So I don't want the tail lifting up on takeoff. See what else I can do here. Let's do a save on this. All right, let's do this one. Let's not do that one. I want to kind of preserve that one. Let's do this one here. All right, so some thoughts on this. Again, I'm going to build this out to be a functional jet first, have all the integrated systems, and then I'm going to go back and do some tilt stuff. And so what I'm thinking of doing is I want to do some engine testing. And so let's go ahead and do some engine testing. And so one of the thoughts is I'm trying to think of the best way to do this. So let's do this. Let's start by grabbing this engine. All right, so let's go ahead and we'll cut this engine and we'll put it up here. And I want to grab the, So I want to make a static test bench. I was gonna do it by grabbing this thing, but you know what? It's gonna save me time to actually build a bespoke test bench. So that's kind of what I think I want to do. So let's go ahead and let's build a test bench. And so what I'm gonna do is I'm gonna build a rig that will test my turbines. I've done it before, but you know it's not a great. I don't have great test benches. And so what I want to do is build this test bench to start with. And so first thing I'm gonna do is just kind of plop this turbine in there. And I'm going to go through and I want to set up a microcontroller here. And so start with the microcontroller. So if you are interested in turbine microcontrollers, I do have a tutorial on turbine microcontrollers, but I'm going to set this one up for a workbench. So what I want to do is composite input, panel, output to panel. All right, and then let's just add a bunch of nodes here, and I'll start working with them in a second here. These are going to be all out of order, just doing it like this, but whatever. Let's go output starter. All right. Input, that should be RPS. That should be a number. Output Rust setting. Let's see, what else do I want here? All right, so some of this I'm going to do outside of the actually do outside of the microcontroller. Again, there's going to be a test bench, so let's start with that for now and get moving here. I think I generally do a 1 as my PID setting, so that's probably what I'm going to end up doing here. All right, so let's go ahead, and this is going to be reasonably simple here. So what I'm going to do is set up a test bench and hook it to a generator, and I'm going to see, again, I want to make the most power generation. This will allow me to build some turbines, hook it up to my test bench, and see how it performs. If it performs well, I know that that model can then go in and should work well. Again, RPS is king. If you think of it like a screw, whether it's an N1 blade of a turbine or it's a propeller in the water or a aircraft propeller, you know, for a set, you know, if the blade pitch is consistent, if it's a set pitch for every one rotation, you should be going a certain distance forward. So say it's for every one rotation, you go 1 meter forward. If you rotate it 1 meter, one rotation per second, you're going to be going 1 meter per second. If you rotate it 100 times in a second, you're going to be going 100 meters per second. And so that's a kind of a good standard way. And so we know that with you know, in the jet engines, I'm using ducted fans. And so I know that if for a certain RPS of the fan blade, I will go a certain speed forward. And that's kind of, you know, that kind of tells me where it is. So if I can monitor how much power I'm producing using a generator, because you need to have resistance, you know, just doing them without any resistance, theoretically you could have a tiny little turbine that's making more RPS because it has no resistance. You put the resistance on and then it's going to be making less RPS than a larger turbine that might natively have more torque but less RPS. And so may be a little confusing, but you'll see it when I get in there. All right, let's see. Thrust setting is going to go there. All right, and then I want, I didn't need to add a node, but I did. Let's see. All right, that's going to be set thrust. Right, and so set thrust is going to be what we're looking for. So RPS is going to be our process variable. Set thrust, we're setting our RPS where we want it. Let's see, let's just do composite read on off 1. We'll make this really simple to get a starter going here. And if it's, so it's going to be if we get a start signal and the RPS, where's less, and so it's going to be if the RPS is less than, where are we at here, RPS is less than, and then 0.5 is when the turbines kick off. So we'll do that. We could do 1 as well. 1's fine. Just constant number right there. So I'll do less than. We do 1. That'll just ensure this starts. And so that will be for our starter. And so hopefully with this test rig, this will allow me to kind of test a couple engine designs, try to get the most efficient engine up and running. So we have that. So my thrust is going to be set off a throttle, which is going to be set to the different RPSs. We'll put a clamp in here. And generally 0.05 to 1 works well for turbines. For clamp value off the PID. That's really all I need. So let's go ahead and start with this. And hopefully we're in business. And like I said, I'll make a test bench. We'll run all this through. So this is the guts of this engine. I want to get the, I want to put this on the test bench, test it out, and then I'll go ahead and see what the dealio is and how I want to change it from there. I'm just going to make a little bit of a control station here. Eventually, I'll probably make this test bench a little bit better so that it has all the readouts so I don't have to go to each engine, and I can probably do them all at one station. But all right, so that's going to be start turbine. All right, let's get this all hooked up here. So this is all set up, and so all I need to do is whatever the output shaft is going to be on this, so this is outputting 2 fans. I can do that. The issue I'm going to have is that intake there actually produces thrust. So it produces a little bit of thrust, so I have to kind of try to think is there a way for me to turn it the other way? I don't know. I don't know, let me try something. We'll see if this works. I don't want the test bench to move. So let's actually raise it up 1. Put on a couple friction blocks. And hopefully this won't move too much on us. The fans are what does the majority of the thrust, and so those will hopefully be, those will be disconnected. So just kind of randomly throwing these in here, get a little bit of surface area, just so we don't end up moving. All right, the back could probably use some. All right, and so let's go ahead and take off symmetry again. So for this motor here, or for this turbine here, I'd come off anywhere under here. And so I'll just cut right here. And this will be, this will go to the generator. And so let's grab a gen. So I'm trying to think, a large generator probably is going to be too much resistance and probably could just stall it out. And so I'm going to do a medium, see how that works. And then what I want to do is a dial. All right, and we'll take the S watts off of this. And then put a throttle in here for the clutch, and one for the one for the clutch and one for the turbine itself. All right, so that's going to be, we'll do like 5%. This is RPS essentially, so we'll do 3 to, let's do 60. This here will be clutch. This will be 0 to 1. We want this really fine tunable as well. So essentially when you're doing a slipping clutch, all you're really doing is changing the gear ratio to, essentially you're not letting the full gear ratio take effect. So that's kind of letting you set a smaller gear ratio. This is set to a 9 to 1 gear ratio at present. All right, and then this is going to go to the thrust controller here. This is going to go to RPS. Let's go compressor RPS. This will go to the thrust setting. Theoretically, if I can grab the line. And then this will be the starter. And then I hook that up. And then I'm not going to worry about electricity. We're going to run it with infinite electricity. And I'll run it with infinite fuel. Infinite fuel could give us some erroneous readings, but we're going to compare it to other test bench candidates and see how it performs. So, okay, so it doesn't like being on those friction blocks, so really doesn't like it. Alright, so I'm going to set it to max thrust, and I'm going to apply the clutch. I know it's bouncing, being annoying, but... Okay, that's going to cause problems. So it's because of the thrust. So one thing I was thinking is to counterbalance the thrust. So one way I can counterbalance the thrust... I see, I can't do it with this motor. Trying to think what to do. Trying to think of a way to... I need to test bench this and have it not move. Maybe magulls would be strong enough. I'm not sure. I just need a strong enough connection that I can... magulls would probably be better. And so hopefully this will hold it in position so I can do what I'm doing here. And so I'm just going to put this on in case I need to move it at some point. Start with that on, and then I will connect them all up and... hopefully this keeps us stationary enough that I can spool up. Okay, so this is the tuning portion, so... let's see where I'm getting this RPS. So it's a 9, so that's less than 2 RPS are coming out of this engine. Okay. I'm going to set this up to 60, and then I'm going to start backing the clutch off. So essentially, the slipping clutch is just essentially allowing you to fine-tune your gear ratio, really. So like I was running a 0.725 on this engine for my jet that I was running there. And so like I was running a 0.725 clutch, and I wasn't even going to 60. I was going to, what was I going to, 45? Yeah, I was going to 45. I doubt that's nowhere near 45, but I'm going to set it at 45. You know, I'll never actually get to 45, but so let's make it 179. So essentially, if I set the parameters correctly, this should show me where it's at. So it's showing 27. It's a 9 to 1. So we're only doing like 3 RPS on the turbine. All right. So this is about what the actual turbines are running when they're in the air. So let's work on trying to really decide the efficacy of this test bench. Let's do something else and see if I can't get these engines to get this to work. So let's go ahead and save this test bench. And let's just kind of, literally wing it. And I'm going to try some new engines on the jet. And so I was getting, I took some notes here when I was testing it earlier. I was getting 289 knots at a clutch setting of 0.725. And again, that's, it's a 9-to-1 clutch ratio, 9-to-1 gear ratio, and then stepping it down essentially. And so I don't think I want to go 4 full engines, 4 of these on it. That's just going to be excessive. So one notion was to build smaller engines. So let's kind of play with that for a second. All right, and so let's start working on this. And I'm just going to make them naked engines for the moment. Just try to get this going here. So I'm doing, they have larger intakes. Let's try some small ones, kind of old schooly small intake jet. All right, we really don't get any benefit going more than 2 turbine sections. So we have compressor, combustion chamber. You want 1 combustion chamber. You start really getting huge fuel usages if you do multiples. Do a couple medium turbines, like so. All right, and so, the length of it's going to be the same pretty much. Let's try hacking one off. Let's try this. All right, and so let's try running this. I should have rotated this. Okay, and so let's try giving this a run. Yeah, so see, this is where the test bench would really come in handy. So let's try going to a full 9-to-1. I'm trying to get as efficient as possible here. That's a 9-to-1. All right, so I can't make the actual nacelles really all that much smaller, so it's really no point in me. I can make them smaller lengthwise, but I can't really make them smaller widthwise because I need to have the fan diameter there. Could. Yeah, see, like I still need to have it under there. That's the issue. If you could put the port in the side, that would be helpful. But you can't, so let's just go in the back here. All right, so that's set up. All right, so in this test bench, I'm gonna. Yeah, see, it doesn't matter having that smaller intake if I have to put a big one on here anyway. I could do some more modern looking turbines if I do it this way. See, the problem is this has to be attached there. I can't put the fan in the front, so the fan has to go in the back. And then see, because the pipe has to go through there, it makes the bottom more bulbous, which is silly. They could have easily made a port there as well and made it a little bit more compact, but whatever. All right, so let me just try this. This is going to be kind of gross. This is not performing badly at all. Trying to get this turbine set up. Let's run it with 4s. See what our performance looks like. See if I'm willing to, if I want to run 4s or not. The answer is probably no, but we'll see. I'd be interested. The fuel usage is going to be, probably not double because I'll be able to run these less stressed, but it's not going to be good. I'll tell you that. So this engine should move out to here anyways, and this one should move on this rib section here, I think. Yeah, you want them staggered a little bit back. And I think that flap won't interfere, so that's pretty good there. All right, I'm just going to paint this. All right, and that way that will be on the other side for me to join. So let's run 4 engines. I don't think it's going to need it. It really doesn't need it. It's a little bit slower than the Cap Air Jet, which was kind of my whole desire was to get at the same speed, but it's not the end of the world if they're not. I'm just curious the performance, more of a curiosity at this point. But I was going to make smaller engines, but you know, I want to use fans. I don't want a bunch of that silly smoke coming out. The smoke just really ruins the immersion for me, and so I don't like to use it. And these wings are hollow because of they used to hold fuel for the Cap Air Jet. Flicking the camera around again. All right, so this goes here. So let's see. Just double check and make sure symmetry is on, because that would be quite sucky if symmetry is not on. But you know, the performance is actually pretty good. There are just some other things kind of now I'm kind of, you know, took a little break, and now I'm kind of rethinking. I don't really need to redo engines, but so one of the things, one of the reasons I want to do the 4 engines for this reason is I'm thinking having a tilt wing is going to be challenging, and I don't mind the challenge, but it could really make performance difficult because having control surfaces on the moving planes and the different moving elements doesn't often work very well, and so I have to be careful of that. All right, so let's go ahead, and we have clutch pressure. I'm going to set that to where I wanted it. So we'll go to the turbine controller, and then fan clutches here. It was 725 was the new number. So I did some testing. 725 worked out best on that. That's what I'm going to give it. So let's see where we're at here. Number 2 thrust settings, going to go to this one. Okay. Number 2 clutch, we don't need. It's going to go off of the fan clutches one. Number 1 thrust setting. So number 1 thrust setting, I'm getting big major slowdowns here, is going there. This is all going to have electricity dialed in as well. All right, where is the thrust setting, fan clutches? So here's the fan clutches. So I need to kind of zoom in and check these. So one set of them is, so that's right there. So I want to check the performance of what 4 engines do. Now, one of the things you can do is, this is something you do in real life, is so if you put a large engine in something, you can run it in a low stress environment where you're really running it, you're down rating it. You essentially are not using all of its power, and that gives you longevity. Generally speaking, the fewer revolutions an engine makes, let's say an engine is good for 5 million revolutions. So of course, the slower you're moving it all the time is gonna, save its life. you know, we don't have to really worry about that in game, but that's kind of the theory behind why they'll de-stress some of these engines. So what's that? 1, 2, 3, 4. Okay. And then so I think the thrust settings are good. Let's see. Number 2 starter goes here. Number 1 starter is going to go over here. And then I'm not going to bother reading off of those. I just need to hook up some electricity here. I wonder if was my turbine disconnected the whole time? I bet this turbine's been disconnected the whole time. Crap. Let's try with 4 anyways. I want to do this test. I bet you my rear turbine, I've had this problem before where I forgot to hook up the rear turbine and it hasn't done anything. That could have been it. Because sometimes you don't hook up that second turbine and it won't work. So that could have actually been my problem. Again, it's performing. It's not performing as well as I would like, frankly. Let's put it that way. Okay. And so is this all connected? Oh, I've been running infinite electricity anyway, so that's fine. Let's go ahead and let's test this. I want to test it with 4 engines now that I hooked up the second turbine. I might not need them, but the thought is, so I've had this kind of notion for a VTOL for a long time, and I might go away from the tilt wing design. If I go away from the tilt wing design, I was actually thinking of clamshells for the back. That will make it so that my control surfaces behave better because it's not on a moving pivot. And then put 2 turbines up front and 2 in the rear, and that will actually make it a hell of a lot easier to program to work. Essentially, you want to yaw. You make the 2 port turbines go forward a little bit, and the 2 on the right side go after a little bit. You want to go pitch backwards. You know, you can do it, you know, using the 4. So there's all different methods to do it. Let's set this in. So this is why I continued with the test. I took a break, so I'm trying to remember where I was. So this should be starting both engines on that side. My my HUD's not connected anymore, I don't think. Okay, there it is. Alright, so all 4 are spinning. So let's do so we need to do some tests here. Let's put the flaps set to 1. Alright, my spoilers come up automatically when I go over a certain speed. That's what they used to do in the Embraer 145. I bet the E-series of jets do that as well. If you're on the ground, so if you have weight on the wheels and you're over a certain speed, they automatically come up. Like Boeing's, you would have to arm your spoilers before landing. The Embraers, you didn't have to do that. They would automatically pop up if you went over a certain speed. I think it was like 20 miles an hour or 20 knots on the ground, which is what I have this set to. So I'm going to set in a bunch of pitch trim. Wow, that was set the exact wrong way. I'm pressing a bunch of buttons here. I don't want to. Here, I'm going to fix that. Okay, so this should be set to like -0.10. We used to actually have to do this before takeoff. You would set your pitch trim. The number was 7. You look on the pitch indicator, set it to 7. So kind of digging the 4 engines. I don't know. The speed definitely should be great. The issue for me is fuel efficiency. And again, I'm trying to make this realistic. I want it to be profitable. But what I can do is I can further... I should have put the clutch as manual because I don't need that much thrust. Like, see, I'm not even at max thrust here. Where am I at? And I'm already pushing really hard here, so let's go ahead. We have to retrim. This is also flying nicer with 4. So what I plan on doing is I want to get this jet finished and usable, and I'll use it a bunch in the career build series. One of the bad habits I have is when I want to make versions of things, I end up not having the jet in a complete, or the vehicle in a complete enough state. And so, you know, you start trying to make a different version of it, and if most of it's not done, well, then you have to try to go back and finish 2 vehicles. And so what I want to do is, if I can get this up and running and working well and tested and kind of the bugs worked out of it and working in a career game, and I'm able to transport containers up to the Arctic no problem, that really gets me in a state where I can then convert it over to a VTOL. So I started out as a VTOL, and you know, a lot of people will see like that's 320. That's a reasonable number. So this is actually definitely going to burn a lot more fuel than the last one was. I have infinite fuels on. I do. Okay, that should be off. Okay, I had infinite fuel on because of the test bench. I didn't want infinite fuel on. So let's actually, I'm going to save this as a 4-engine jet. So again, the plan with this is I'll get a version done. And then once it's, you know, pretty close to being done, or as whatever done means, I will then make a version that's a VTOL. And so I like the tilt wing design, but, you know, I'll have to see. You know, having the two, you know, putting the wings on pivots can cause issues. And the bigger the vehicle, the more likely you're to have glitch issues. I'm pressing my down arrow, but my thrust is not coming back. I had this issue before. I don't know what it is. I can't bring them back singly. I'm going to run into huge problems. Okay, so... Okay, let me bring this back in the workbench. Something screwed up with this. But we'll finish up here in a second. This is... Let me try to fix the seats. Why is it doing this? Let's see. Up, down is reset. Thrust 100%. Yeah, so that should be pulling the thrust back, but it's not. Yep, that's okay. So that should be pulling back. It's not. So kind of the thought is what will happen is essentially, let's save this as cargo plane, 4 engines. So we're easily doing, so I was running at 45 RPS. And at 45 RPS before, I was with a 9-to-1 gear ratio and a clutch set to 0.725. I was able to get up to 289 knots in the 2-engine version. And this one, I was at about 35 RPS set, and I was able to get up to 320 with the same clutch setting. And so one thought I have is this is, you know, so I don't know if it's linear. Let me quickly kind of do the math here. So if we think about it, I'll bring up so you can see the calculator. So the thought is this. So I had 2 engines running at 45. That gives me 90 RPS, right? And then I had 4 engines, right? And they were running at 35. That gives me 140 RPS. All right, so let's think of RPS as our fuel burn. All right, so now if I took 90 divided by 4, if I got similar performance and I could run the 4 engines at 22.5 RPS, potentially I could get, I could equal the fuel burn of the other jet. So that's kind of a thought as well. And so I wanted to test out the 4-engine version. The 4-engine version works beautifully. And so again, the goal with that is going to be this. So kind of my thought process is we'll just make it really super dirty here, just so you can see it. But you know, you have to consider where your jet thrust is going to go, and you don't want to put that jet thrust into another turbine because that's all, you know, you've used up most of the oxygen, and you're putting, you know, essentially burned fuel out there, and the other turbine's trying to suck it in. That's really not good. And so what I'd essentially do is put it here. I'm just going to keep them pink. I'm not going to keep them, but let me see where we're at here. So I can't go there. Let's go here. Oh, come on. Flicking my camera around. Sorry about that. And so essentially what this would do is we want fluid pivots because we need to be able to put fuel in there. And so where we need to reach here. All right, so you'd put the 2 there, and then I would grab these. So this would be the conversion to a VTOL. And so you come in here and you cut this one, and then this would go. They're actually, you know, they used to be mounted sideways because they were on the Cap Air jet. And so the turbine would come up and it would cozy in on this pivot here. And so essentially this would go like this. This is going to be, I think, a much better system, and it's going to make the controllability of the aircraft much better. It's also going to give me much more reliability with the... Ooh, that engine is huge. That's the problem, is the engines are absolutely enormous because of the size of the fans. See how enormous that is? That's the issue. That's just too big. They look funky. If these engines were like half the size, like, see, the problem is that I have to use smoke, and I don't want to use the smoke because I can't get the diameter any smaller using using the fans. Because you see here, a fan is... Here's a small ducted fan. You notice its diameter. You know, that's about as small as I can get it. You know, so that's probably... I'm not going to want to do that then. So I'll probably go back to a tilt wing. That's going to cause me issues. The other notion is... I can't do that. Yeah, I'd have to think about it. But let's do one more quick test and then we'll get out of here. So here's the cargo plane engine rework. And so I saw a mistake. No, that wasn't a mistake. I have infinite electricity on. So this doesn't matter because I had infinite electricity on. Okay. Yeah, I had infinite electricity on, so that shouldn't matter. Let's go for one test and I'll show you what this looks like. I have to fix something really quick here. So we'll go for a test flight and I'll show you what the performance on this looks like. So fan clutches should be 725. Let's actually... All right, let's spawn this. And I'll take it up for a quick flight. We'll just get up to max speed and then we'll come back. And so I'll show you the performance of this, and then we'll call it a video there. But yeah, so this is kind of, you know, the engine tuning phase and trying to get it running. You know, I'm trying not to make any smoke with these turbines, and so I'm using the fan clutches, and I'm using the torque off of that, because, you know, you wouldn't get any quote-unquote smoke out of these engines until you're up, you know, over like 30,000 feet, you know, when you start making contrails. And so I kind of hate that in game that they have them on there, you know. And I think it's, you know, it's always a good thing to have options where we can shut that stuff off. Let me double check. Infinite electricity should be on infinite fuel. So let's go ahead and do a quick flight on this. See where we're at on this. You know, so there are a bunch of tricks to make these turbines more powerful. You know, I'm just doing it the simple two turbines. You can make a little bit more power by putting one of the small turbines on there, but all it does is it's, you know, it is not giving you extra torque because you don't have a torque connection on that. And once you go over that, you're really not getting any benefit. So if you go to 3, you know, I wasn't getting any benefit off 3. See, I'm having a pitch issue because I didn't fix the pitch in this one. Okay, let me just go ahead and slam that autopilot on. Let's go gear up. Let's go flaps up. So I'll just show you the max speed on this one. And so there's a lot of tuning to be done with this. One thing I can do is, so currently it has a 9:1 gear ratio, and so I have it set to 45. I doubt it's getting anywhere near 45. But it has a 9:1 gear ratio on there and the certain clutch setting, and so what I need to do is back off the gear ratio essentially to get a little bit more speed out of it. But it's not bad. As you can see, it will get up to about 289. So that's currently what we're looking at. You know, it's, I don't know, some people are probably disappointed that it's not a VTOL, or it's not gonna, I'm not gonna keep building as a VTOL right now. I will go back at some point and try to make it a VTOL. I would like to do tilt wing like I originally did, but there are a bunch of issues with that. I actually did a vertical takeoff and it took off vertically fine. That wasn't an issue, because what I have to do is I have to tilt one wing forward and one wing back to yaw. I'd have to tip the wings to pitch the aircraft. So it's not that bad, but I have to tune all that in. And then we get some weird physics behavior with the pivots. We also lose our aileron effectiveness. Like, I was really struggling to roll because with them on a pivot, it's weight-based, so I'd have to cheat in control surfaces and hide them somewhere in the main body. I could hide them in the gear wells, but I don't like doing all that crap. So, you know, I want to make this airplane work well, and then I'll kind of convert it into a VTOL. And I think that's going to be a better way. Make a plane that works really well as a plane, and then go ahead and convert it. So, hope you guys enjoyed it. We'll see you in the next one.